हेलो, नमस्कार दोस्तों। आई एम डॉक्टर करुण गुप्ता, एसोसिएट प्रोफेसर इन डिपार्टमेंट ऑफ मैकेनिकल इंजीनियरिंग, जीएल बजाज, ग्रेटर नोएडा। आज हम डिस्कस करेंगे फीड वाटर ट्रीटमेंट। इससे पहले मैं आपको ये बता दूं कि ये जो सारा नोट्स हैं, लेक्चर हैं, ये पीपीटीज़ हैं, ये सब हमने नेट से स्लाइड शेयर डॉट नेट से ली हुई हैं और इनका जो सोल पर्पज़ है वो सिर्फ अपने स्टूडेंट्स को एजुकेशन देना है। इसका कोई कमर्शियल पर्पज़ नहीं है। और दोस्तों, काफ़ी समय के बाद मैं ये एक वीडियो शेयर कर रहा हूँ आपसे। कुछ ज़रूरी काम की वजह से हम बिज़ी थे, सो इसलिए थोड़ा सा टाइम लग गया हमें ये नेक्स्ट वीडियो देने में। सो बाय द वे, आज का जो हमारा टॉपिक है वो है फीड वाटर ट्रीटमेंट। दोस्तों, थर्मल पावर प्लांट में हमें वाटर की ज़रूरत होती है। मैंने आपको पहले भी बताया था कि वो वाटर जो है वो बॉयलर में चाहिए, और बॉयलर में वाटर की स्टीम बनाते हैं और उस स्टीम से हम टरबाइन को रन करते हैं। इसके बाद जो हमारी वेट स्टीम निकलती है तो उस वेट स्टीम को भी कूल करने के लिए हमें वाटर की रिक्वायरमेंट होती है। सो दोस्तों, वाटर जो हमें अवेलेबल है, वाटर के हमारे रिसोर्सेज होते हैं कैनाल, रिवर, पॉन्ड एक्सेट्रा। बहुत कम केस में हम लोग ग्राउंड वाटर को यूज़ करते हैं, क्योंकि वाटर की रिक्वायरमेंट बहुत ज़्यादा होती है और ग्राउंड वाटर सफिशेंट नहीं है उस रिक्वायरमेंट को पूरा करने के लिए। सो हम नेचुरल सोर्स जैसे कि कैनाल, रिवर, पॉन्ड एक्सेट्रा को हम लोग यूज़ करते हैं। और यहाँ पर वाटर is not available in its purest form. That's why we need treatment of the water. सो उस वाटर को हम प्योरीफाई करते हैं, उस वाटर से हम इम्प्योरिटीज़ को रिमूव करते हैं। और हम इसका जो इस थर्मल पावर प्लांट का जो सिलेबस है, ये हमारी यूनिवर्सिटी AKTU लखनऊ ने दिया है। सिलेबस आपके सामने है और इस सिलेबस में आप देख सकते हैं ये जो टॉपिक आप देख रहे हैं, दिस इज़ फीड वाटर ट्रीटमेंट। सो दोस्तों, आज हम डिस्कस करेंगे फीड वाटर ट्रीटमेंट की। पर पहले आपको ये पता होना चाहिए कि फीड वाटर का जो ट्रीटमेंट है उसको क्यों करते हैं, क्योंकि वाटर में बहुत सारी इम्प्योरिटीज़ अवेलेबल होती हैं। सो कौन कौन सी इम्प्योरिटीज़ अवेलेबल है यहाँ पर हम लोग डिस्कस करेंगे। सो जैसा मैंने यहाँ पर लिखा है नंबर 1 पर, अनडिजॉल्व एंड सस्पेंडेड मटेरियल्स। सो आप देख सकते हैं टर्बिडिटी, सेडिमेंट, सोडियम एंड पोटेशियम सॉल्ट्स, क्लोराइड्स, आयरन, मैग्नीज, सिलिका, microbiological growth, color, and water may be of different color. So these are the undissolved and suspended materials. और इसके बाद जो सेकंड कैटेगरी हमने लिखी है यहाँ पर, दैट इज डिजॉल्व्ड सॉल्ट एंड मिनरल्स। सो कैल्शियम एंड मैग्नीशियम सॉल्ट्स आर डिजॉल्व्ड. There are some dissolved gases also, oxygen, carbon dioxide, and some other materials may also be present in the water, that is free mineral acid and oil. So we have to remove all these impurities one by one. अगर हम बात करें कि इम्प्योरिटीज़ का इफेक्ट क्या होता है, तो यहाँ पर हमने एक लिखा हुआ है कि स्केल फॉर्मेशन, यू कैन सी दिस इज़ अ बॉयलर ड्रम है और इस बॉयलर ड्रम के अंदर वाटर है। वाटर के अंदर कुछ इम्प्योरिटीज़ हैं। सो वेन एवर वी अप्लाई द हीट टू द वाटर, आप देखिए इस वाटर की जो वॉल है, इस वॉल की थिकनेस काफ़ी कम आपको दिखाई दे रही है। ठीक है, वॉल की काफ़ी कम थिकनेस इसलिए है कि यहाँ से हीट आसानी से ट्रांसफ़र हम कर सकें। बट ये जो इम्प्योरिटीज अवेलेबल है वाटर के अंदर, आप देख रहे हैं ये जो ब्लैक ब्लैक स्पॉट्स हैं, जिसको हमने लिखा है लूज प्रेसिपिटेट सस्पेंडेड इन वाटर और स्लज। सो वेन एवर वी सप्लाई द हीट टू द वाटर, ये इम्प्योरिटीज जो है ये आप कह सकते हैं सॉल्ट की टर्म में, एक हार्ड एडरिंग की टर्म में, कोटिंग की टर्म में इनर वॉल के साथ अटैच हो जाती है। और आप देखेंगे धीरे धीरे वॉल की जो थिकनेस है, इस वॉल की, वो बॉयलर ड्रम की बॉयलर वॉल की थिकनेस को आप कंपेयर करें, सो इन सेकंड केस द थिकनेस ऑफ बॉयलर वॉल इज मोर बिकॉज मटेरियल इज सेम, बट इनर साइड में इसकी हार्ड एडरिंग और कोटिंग यहाँ पर ऐड होती जा रही है। और ये जो हार्ड एडरिंग और कोटिंग है, इसकी वजह से बॉयलर की शेल की थर्मल कंडक्टिविटी कम हो जाती है। और इन सिंपल वर्ड्स वी कैन से कि जो हीट ट्रांसफ़र कैपेसिटी है बॉयलर शेल की, बॉयलर ड्रम की, बॉयलर वॉल की, ये कम हो जाती है और वाटर को हीट कम अवेलेबल हो पाती है। इसका हम आपको एक और एग्जांपल दे सकते हैं। कुछ लोग घर के अंदर वाटर नहाने के लिए पानी को बर्तन में बॉयल करते हैं। अगर आप देखेंगे कुछ टाइम के बाद बर्तन पर वाइट वाइट एक लेयर जमनी शुरू हो जाती है। सिमिलरली वी आर यूजिंग इमल्शन रॉड, पानी गर्म करने के लिए इमल्शन रॉड यूज़ करते हैं। आप देखेंगे थोड़े टाइम के बाद उस रॉड पर एक वाइट वाइट लेयर कलेक्ट हो जाती है। सो दैट लेयर इज ऑफ सॉल्ट्स। और उस लेयर से हीट ट्रांसफ़र कैपेसिटी कम हो जाती है। इसकी रिएक्शन हमने यहाँ पर दी हुई है। अगर कैल्शियम के या मैग्नीशियम के सॉल्ट्स हैं तो CaHCO3 होल ट्वाइस प्लस इसमें हमने हीट ऐड की है। 100 डिग्री हमने टेम्परेचर लिखा है एट एटमॉस्फेरिक प्रेशर, सो व्हेन एट 100 डिग्री इट कन्वर्ट इनटू CaCO3 plus CO2 plus H2O. Similarly for MgHCO3 whole twice, it will convert it to MgCO3 plus CO2 plus H2O. सेकंड जो इफेक्ट है, फर्स्ट इफेक्ट हमने बताया स्केल फॉर्मेशन, आप देखेंगे। सेकंड इफेक्ट यहाँ पर है कोरोजन। सी कोरोजन इज नॉट रिक्वायर्ड। कोरोजन इज द डिस्ट्रक्टिव कन्वर्जन ऑफ मेटल इनटू ऑक्साइड्स और सॉल्ट्स, so it cause bearing of boiler metal and it produce pits, grooves and cracks on the boiler surface. Corrosion on inner surface of boiler tube is mainly due to presence of dissolved oxygen in boiler feed water. Carbon dioxide is next to oxygen, which is responsible for corrosion. Dissolved CO2 in water form carbonic acid. So here we have shown a reaction. You can see CO2 plus H2O, which convert into H2CO3. A carbonic acid react with iron and other metal to form bicarbonates. So they are decomposed by heat and CO2 is again liberated. Or when CO2 is again liberated, it will mix with the H2O and again it form carbonic acid. Then carbonic acid again form bicarbonate and liberate CO2. So this cycle will continue and continue and continue. Third one is priming, forming and carryover. Due to presence of soluble and insoluble salt in water, steam passage is filled with mass of frothy bubbles, which is known as foaming. Foaming can be reduced by adding castor oil, anti-foaming agents, and by adding sodium aluminate. During rapid steam production, some water droplets are also carried along with steam as it leaves the boiler. So the wet steam formation is called priming. Priming and foaming occurs together and is referred as carryover. Following precautions should be observed to reduce foaming and priming. Oil, soap, and other suspended impurities should be removed from boiling feed water. Various valves should not be opened suddenly to the maximum. So valves must be opened slowly. Water in the boiler should be at its maximum possible level. Fourth effect is the caustic embrittlement, caused due to presence of caustic impurities present in the water. Presence of certain concentration of NaOH and silica cause embrittlement. Presence of NaOH makes the metal brittle and inner crack appear along the along the seam below the water level. NaOH flow into minute hair cracks of the boiler surface by capillary action, and it can be prevented by adding sodium phosphate as softening agent, addition of organic agents like tannin or lignin, and addition of Na2SO4 to the water. आप देख सकते हैं, दिस इज caustic embrittlement. There is a hair crack. This crack will increase and further this will happen. Right. Now what is the role of pH in corrosion and scale formation? See, pH को हम कहते हैं, pH is the power of hydrogen. pH value of water is the logarithm of reciprocal of hydrogen ion concentration in water. If concentration of hydrogen ion in water is 10 raised to minus 10, then pH value of the water will be, हमने कहा logarithm of in reciprocal of, so we write log of 1 by 10 raised to the power minus 7, which is equal to 7 at 20 degrees Celsius. So when pH value of the water is 7, it consider as good water, uh, right? So pH value varies from 0 to 14. A sample of water having pH value less than 7 indicate acidity of water and more than 7 indicate alkalinity of water. So as the pH value is a logarithm function, so solution having pH value of 6, 5 and 4 are respectively 10, 100 and 1000 times more acidic than the solution having pH value of 7. So we want that the water should available at pH value 7. What is the role of pH? The corrosion rate of iron in absence of oxygen is proportional to pH value. At lower pH value, iron will be more soluble. The oxygen in the water unites with ferrous hydroxide to form ferric hydroxide. The pH value of feed water should be kept greater than 9.6. I think all these things you have covered in your chemistry plus 2. Corrosion rate increase due to presence of dissolved oxygen and carbon dioxide in water as concentration of hydrogen ions increase with increase the pH value of water. Now we will discuss the water treatment system. One is internal water treatment system. In this method, dissolved solid are removed in boiler itself by adding chemicals either to precipitate the impurities so that they can be removed in the form of sludge or to convert impurities into harmless salt. So there are various methods are available. The one method is sodium carbonate treatment, other is phosphate treatment, other is sodium aluminate, other is colloidal treatment, and one is blowdown system. If we are talking about sodium carbonate system, the sodium carbonate system, so सोडियम कार्बोनेट ट्रीटमेंट की हम लोग बात कर रहे हैं. So dissolved solid are removed by adding sodium carbonate, that is Na2CO3, or we can say it is soda ash, to boiler water. So here CaSO4, which is impurities, calcium sulfate, which is impurities. So we are adding here soda ash, Na2CO3, which convert into CaCO3, which is insoluble, and Na2SO4. And this Na2SO4 when comes in contact with water and getting heat, it convert into NaOH and H2O and CO2. And this NaOH, so to remove this NaOH, we add MgSO4, magnesium sulfate, and when this magnesium sulfate comes in contact with NaOH, it convert into MgOH whole twice, which is sludge, and then Na2SO4. So we can remove this sludge. फॉस्फोट ट्रीटमेंट की अगर हम बात करते हैं तो स्केल फॉर्मेशन अवॉइडेड बाय एडिंग सोडियम फॉस्फेट. यू कैन सी CaCl2 is available, which is as impurity, so we add here Na2PO4, that is sodium phosphate, which convert it into Ca3PO4 whole twice plus NaCl. Right. So monosodium phosphate, which is used for highly alkaline boiler water. Disodium sulfate is preferred for moderate alkaline boiler water, and trisodium phosphate is preferred for less alkaline water. So you have to see which type of water is available. So before applying the sodium phosphate, you must know which type of water it is, whether higher alkaline or moderately alkaline or less alkaline water. Next one is sodium aluminate. So here the scale formation can be avoided by using sodium aluminate to the water. Whenever we add sodium aluminate to the water, it convert into NaOH and AlOH whole twice. Also, this NaOH whole twice comes in contact with MgCl2. It convert into MgOH whole twice plus NaCl. Next one is colloidal treatment. It is used for low pressure boiler to prevent scale formation by adding organic substance like tannin, starch, lignin, kerosene. Coating of these substance is formed by over scale forming precipitates. It results in formation of non-sticky and loose deposits similar to sludge, which can be removed by blowdown. Now blowdown system, you can see here in the blowdown system, there is a boiler drum. In this boiler drum, water is filled, and when we supply heat to the water, some water convert into the steam, which can be collected from the top. Now the impurities which is settled down at the bottom, they can be removed from here, which is blow down. अब हम बात करते हैं यहाँ पर एक्सटर्नल वाटर ट्रीटमेंट की. सो व्हेन द क्वांटिटी ऑफ मेकअप वाटर इज लार्ज एंड इट कंटेन कंसिडरेबल सस्पेंडेड एंड डिजॉल्व्ड impurities, then internal water treatment is not enough, so we have to use external water treatment. In this method of treatment, raw water is taken to a tank where reagents are mixed. So various methods are available for external water treatment. One is mechanical method. In this mechanical method, we are doing sedimentation, coagulation, filtration. There is thermal method in which distillation, sedimentation, and deaeration is done. And next one is chemical treatment, where lime soda treatment, zeolite process, and demineralization is done. Now we are talking about sedimentation. See what sedimentation. Sedimentation means In this method, water is allowed to remain stand still in a big tank or to allow to flow at very low velocity. The solid matter settle down due to gravity, which can be removed periodically or continuously. Clean water is taken from the surface of the tank. And I just want to tell you one thing, that not any single method is sufficient to treat the water. So we have to use more than one method. So here we have shown a diagram where this dirty water is kept in a beaker. After some time, when the solid impurities settle down, so we remove the water from the top surface. Next one is coagulation. In this method, some coagulant like aluminum sulfate, sodium aluminate, or ferrous sulfate are added to the impure water. Reaction between these salt and alkalities in the water cause smaller particles to adhere to each other, forming large particle. And when there are large particles, the large particle are settled down and can be removed by filtration method. So you can see here, this water is this water is the same which you have to uh, clear or which you have to filter. So here you can say there are damaged blood cell, injury to vessel lining trigger the release of clotting factors, right? So when we add some uh, coagulation material, so these become a blood clot. Filtration. In this method, water is allowed to pass through gravity or pressure filter. By increasing the fineness of filtering element, maximum suspended impurities can be removed. The suspended matter adhere to the filter material and clear water drain from the bottom. It is necessary to clean the dirt collected in the void of filter metal periodically by backwashing the filter material. You can see here, this water is mixture of water and sand. So here we are using a funnel, and in the funnel we are placing a filter paper. So when we allow this water to pass through this filter paper, only water passes the filter paper, and all the dust particle or sand particle are not allowed, so they are here. So this is the residue. So time to time we have to remove this residue. You can see more clearly in this water. This is a filter paper. These blue small balls are water particles and bigger balls are impurities. So impurities are chalked or kept here, stopped here, and water particles are allowed to pass this filter. Next one is distillation. So in the case of distillation, the raw water is filled in a tank, and we supply the hot air or steam from the boilers, and it pass through the water, and then it come back to the plant. And this hot water or this heat allow the water particles to evaporate. So when evaporate particle or steam particles are purest form of the water, which can be collected from the top and can be used for further processes. Next one is the distillation. So here you can see the distillation, evaporation. There is a flask where water and ethanol solution is there. We apply the heat. So whenever we apply the heat, vapors are vapor are come out, and those vapor can be collected in a beaker through the tubes. You can say this is second case where pure ethanol vapors can be collected from the water by the same case, right? So, in this method, raw water is evaporated utilizing blood steam from the boiler. The steam from boiler flows into tubes and get condensed after transferring the heat to water, as shown in the figure. You can say in the figure itself, this is the figure. The condensate is returned to boiler as feed water, and the water from the top surface, that is steam from the top surface, can be collected and condensed to supply pure feed water. Next one is de-aeration. So you can see there's a diagram of de-aeration, right? In this diagram you can see that there is a tank where water is filled, right here. You can say in the here in the aeration, this water is supplied here, and hot water or steam is supplied from this passage. So when this hot water or this steam comes in contact, right, it get cooled down and water collected here and air moves outside, and from there here water can be supplied through the help of water feed pump. There is one hot lime soda process. Again, you can see in this diagram we are using hot lime soda processes. Here raw water is supplied here, and superheated is steam is supplied here. Chemical, that is lime soda and lime and soda, we supply here. There is a reaction tank where it got reacted, and all the impurities settle down in the bottom in the form of sludge, CO, CO3, MgOH, salt waste, etc. From bottom they can be removed, and the water, which is comparatively soft water, can be supplied to another tank where it can further process. Right, same thing you can see here. So if we are talking about hot lime soda process, chemical reactions takes place are listed below. The carbonate hardness is removed by hot lime. You can say here CaHCO3 plus CaOH whole twice is converted into CaCO3 and water, right? And MgHCO3 whole twice, it also get reacted with CaOH whole twice, convert into CaCO3 and MgOH whole twice and water. The sulfate hardness of calcium and magnesium is removed by soda ash. So here you can see CaSO4 plus Na2CO3 convert into CaCO3 and Na2SO4. MgSO4 plus Na2CO3 convert into MgCO3 and Na2SO4. Right, the chloride hardness of calcium and magnesium are removed by soda lime respectively, as you can see here. CaCl2 plus Na2CO3 convert into CaCO3 plus NaCl. MgCl2 plus CaOH whole twice convert into MgOH whole twice plus CaCl2. Sometimes trisodium and caustic soda are also used in addition to lime and soda. Phosphate is very effective in removing calcium and magnesium salts. So CaHCO3 whole twice plus NaOH convert into CaCO3 and Na2CO3 and water. Similarly, MgHCO3 whole twice and NaOH convert into MgOH whole twice and Na2CO3 and water. Similarly, CaSO4 and Na2PO4, Na3PO4 convert into Ca3PO4 whole twice and Na2SO4, and MgSO4 and Na3PO4 convert into Mg3PO4 whole twice and Na2SO4. Right, what are the advantage of hot lime soda process? See, the process is very much economical. It is capable of treating large quantity of water in a relatively small unit. pH value of water rise, which improve the corrosion resistance of water. Silica is effectively removed from the water. The size of centering tank is reduced as precipitates is larger in size and settle more quickly. But I always told you, when there are advantages there are disadvantages. So some disadvantages are: softness produced by this method is less than zeolite process. Huge amount of sludge is formed and disposal is difficult. Controlling of hot process is difficult. The softened water must be filtered to avoid precipitates being carried with softened water. Backwashing of filter periodically is required to increase the efficiency of boiler. Now there is zeolite exchange process. In this process, you can say there is a zeolite bed, right? And that bed is supported by gravel or anthracite. Here we are supplying the NaCl solution. We supply it and we supply the water. You can say we supply the water, right? So in this case, there is a this is raw water, and raw water is supplied through the meter. So here you can see there is a chemical reaction, and after chemical reactions the fresh water can be collect from the here, and waste or drainage can be from here. So there are various advantages of zeolite process, that hardness of water can be removed almost completely up to 10 ppm. There is no sludge formation, hence the process is clean. The process automatically adjusts itself for different hardness of incoming water. The equipment used is small and easy to handle, and it required very less time for softening. It is not necessary to filter the soft water as it required in lime soda process. But disadvantage, that turbid water cannot be admitted to zeolite bed as it makes the bed inactive. Hence, suspended impurities must be filtered before passing over the bed. So सस्पेंडेड इम्प्योरिटीज़ को आपको फिल्टर के थ्रू आपको रिमूव करना ही पड़ेगा, कोई और चांस नहीं है. Water with high or low pH value damage the bed of zeolite, so pH value must be constant. On removal of Ca and Ca2 ions and Mg plus 2 ions, the soft water contain large amount of NaHCO3, which on heating liberates CO2, which can cause the boiler. So these are the few disadvantages of this zeolite process. Now we are talking about demineralization plant. So in this case, demineralization plant, raw water is supplied from here where H2 H2Z cation exchanger, then it is passed through an ion exchanger, then it is passed through degasifier, and from the degasifier, air air is allowed to go outside, and then that water is supplied to the silica absorber, and after that soft water is available for working. So if we are discussing about demineralization plant, the exhausted cation resins can be reactivated using H2SO4 or HCl, where an ion can be reactivated using NaOH or Na2CO3. The various advantages are that high quantity pure distilled water in the range of 0 to 2 ppm can be obtained. Water obtained is free from dissolved gas and silica, but disadvantage is also that this equipment is very costly and operating cost is very high. One more process which is known as RO process or reverse osmotic process. See, you know osmotic process. So here we are doing the opposite of osmotic process, which is known as reverse osmosis process, and you have read this process in your +2 chemistry very well. So and then you can say this is a reverse osmosis process where we are using a semi-permeable membrane filter type. This is like a filter, and the raw water or salt solution is there, and when pressure is applied, some water particles are allowed to pass through this semi-permeable member. So that is purest form of the water, and rest water is allowed to drain. So what are the advantage of RO process? It is an efficient method of removing salts, chemical contaminants, and heavy metals such as lead from drinking water. Lead from drinking water. It is cheaper than ion exchange process for water containing dissolved solid of 200 ppm or more. It is very simple to operate and maintain, but there are disadvantages also, that here membrane is most costly item, and membrane must be cleaned at regular interval, and it must be replaced after every 1 to 3 years depending on water quality and size of the system. Pump used require regular maintenance. Even we are using. So sea water treatment is also required RO process. So in this case, you can say this there is RO process, that there is a media filler, cartridge filler, high pressure pump, RO perimeter blank, saline reject water, and pure water is available here. This is the sea water. Sea water is lifted with the alcoholic pump, where chlorine, coagulant, and acid treatment is there. After that, this water is supplied through media filler, cartridge filler, then RO, saline reject, etc. And here the reject water is there, and this water is which is used for boiler, which is the purest form of the water. So friends, this is all about the water treatment for the power plant, right? So thank you friends for listening carefully. Thank you very much.